SCSP. Please welcome our speakers, the Honorable Mark Menezes, President and CEO of the U.S. Energy Association, Chris Mowry, CEO of Type 1 Energy, and Andrew Campbell, Senior Manager of Construction Management at Tennessee Valley Authority.
All right, good afternoon, everyone. How are we doing? All right, late in the afternoon. Can I get a sign of life? All right, cool. Good, enthusiasm is high. As we know, states and localities are where the rubber meets the road when it comes to deploying and scaling any technology, but in this case in particular, fusion technology. As a fellow Tennessean, I'm excited to have the opportunity to shine a light on the volunteer state as a testing ground for fusion energy. So joining me here on stage is Mark Menezes, the President and CEO of the U.S. Energy Association, former Deputy Secretary of Energy, and most importantly, a Commissioner on SCSP's Commission on the Scaling of Fusion Energy. Next to him, we have Mr. Chris Mowry, CEO of Type 1 Energy. And then lastly, but not least, Andrew Campbell, the Senior Manager for Construction Management at the Tennessee Valley Authority. So let me start with you, Mark, from your perch, both as a former DOE official and as the CEO of USEA. Can you describe to the audience some of the dynamics that you see between the federal and the state level from a regulatory perspective, but even from a stakeholder perspective? When it comes to fielding these kinds of first-of-a-kind technologies. What were some of the key connective tissues missing from what you could tell at these two different levels of government?
Yeah. Well, thank you very much, David, for the question, and thank you for having me here. It's really an honor and a privilege to be here to talk about such an exciting topic, really, that has come a long way just in my days of working over at DOE. You know, when you're at the Department of Energy, you really are filled with enthusiasm of all the various science projects and things that you can get involved in, you know, with the 17 national laboratories. And fusion was a key part of the Office of Science. And so it was in the Office of Science, interestingly, not in the Office of Nuclear Energy Program, because Congress at that time had really seen it more of an investment in proving the science. And so our goal over there was to really try to move it, to position it into actual real fusion projects. And so if you go back and you look at the funding, both through ARPA-E and other ways that we funded projects, fusion, it was really to further that demand. And so what you look at when you're there as a steward of your nation's resources and where it can be deployed and what science you want to develop, certainly in the energy space, fusion, you know, was a real potential candidate. But the key is, of course, to actually get it out of the government, if you will. And so you look for opportunities to where you can bring in both potential private investors, as well as the support of the Department of Energy in this case. Further, it would be helpful to get one of the national or several of the national laboratories involved. And since you're in the world of fusion, principally to look at the creation of electrons to put on the grid, you begin to have even a practical approach to say, well, where could such a project be deployed as we moved across the technology readiness levels? And so that's what you hope for. You hear of these public-private partnerships, and I think today our panelists will discuss almost how all these things really came together, where you had the support of the Department of Energy. Importantly, you had the support of the National Laboratory. You have the support of the state, where you have a group of willing parties all coming together. You have private interest. And I will say one other thing that was a major push in serving with the Department of Energy, and that was to look forward on the regulatory landscape to see what the NRC would expect as these developing fusion technologies, were they going to hold it to fission standards, et cetera. You got to go back several years, but that was a real issue back then. a lot of the work we did there was working with the NRC to try to get it to look at more like medical isotopes. Congress got involved in it with the ADVANCE Act, and so I think you see a good regulatory process in place. And we're going to hear about the state of Tennessee, which was a signatory of the agreement of the states, and their legislatures working, their governor supports it, and I think you'll hear a very good story today.
Yeah, Chris, Type 1 is approaching fusion from a very unique architectural standpoint, the stellarator design. Can you talk a little bit about why you're especially bullish about the stellarator architecture, and what about today in 2025 makes the timing ripe to continue trying to experiment and deploy this kind of technology?
Well, that's a really great question. You know, I approach fusion not from the perspective of a plasma physicist, but from a person who's spent his career in the global energy industry. And so what I found compelling about Stellarator that to me is actually today somewhat unique, actually completely unique, is that right now the Stellarator is the only fusion technology that has been demonstrated to operate in a stable and steady state manner. And from my perspective as someone who has been in the energy and the power industry, so far that's pretty fundamental to a practical power plant, and a power plant that will be importantly that complement to the intermittency that renewables bring to fusion, to the energy space in the power grid. So I think what the industry is looking for, the energy industry, is this on-demand, reliable complement that can be scaled, that is this counterpoint to the renewables, because there's a lot of renewables, there will be more renewables, and they play an important part in the future of energy. But the power grid, as has been demonstrated earlier this year in the Iberian Peninsula, also needs inertia, and it needs baseload energy, and that is something that fusion can bring. And when you think about what that means that you need to be generating continuous, reliable power. And so in the first instance, one of the things that today is unique about the Stellarator is that it in fact has been demonstrated to operate in this steady state, continuous manner, and that's just pretty fundamental. The second thing is that about 3 or 4 years ago, we reached the point where you could, with reasonable extension and development, see your way to actually engineering a first-generation fusion power plant. And I was struck by something that Andrew Lowe said earlier on the financing side, because you need to have a solvable problem here. And I think creating a solvable problem is probably fundamental to this conversation that we're having here in many different ways. But one of them is that you need to be able to put forward an approach that is at its heart an engineering challenge and an infrastructure challenge from a project perspective. An engineering project, a hard engineering project, make no doubt about that, but an engineering project and an infrastructure project, not a science project. And when you get to that point, then you can actually start to talk about commercialization. And so having that nexus of technology that's been demonstrated to operate in a stable, steady state manner, and a set of fundamental technologies that can be used to translate that fusion platform into a first generation power plant is something I think that today is unique about the Stellarator.
Now, moving over to you, Andrew, Tennessee Valley Authority occupies a really unique space. It's the nation's largest publicly owned utility, but TVA also has the commercial flexibility and a regional focus in particular. So can you talk a little bit about TVA structure? We were talking about this a little bit backstage. Talk about TVA structure and some of the authorities your agency has, and how that enables you to engage with startups like Type 1, and we'll talk about more that cooperative agreement later.
Yeah, absolutely. So we were a federal agency founded in 1933. It was the Great Depression. There was a lot of blight, economic depression in the valley, and we have 3 principles: energy, environment, economic development. Those are the 3 things that TVA as an agency strives for in our customers, and We serve a 7-state region. It's all of Tennessee, Mississippi, Alabama, Georgia, Virginia, Kentucky, North Carolina. And those customers are really where all our funding comes from. While we're a federal agency, we get no appropriations. So it's all rate funded, and what we do and everything we do is for those customers through our least cost planning models. So as part of the background, we undertake innovation to seek advantages for those customers, advanced technologies to make their lives better, their rates cheaper, more competitive, more affordable. And that's one of the areas that we can interact with companies. It's a little different than maybe traditional IOUs. As long as we've got a good case and belief, we've got a little flexibility in how we interact.
So maybe we can talk about the agreement or the deal that TVA has with Type 1. So for Chris and Andrew, in the Tennessee context, can you describe to the audience some of the details of this cooperative agreement? And specifically, I'm struck by the number of stakeholders involved here. We have Type 1 and TVA, we have Oak Ridge National Lab, and the state government is also a stakeholder in making it all happen. In addition to that, the agreement takes place on a brownfield site, an old coal factory. So I invite you to share some details about that project and how you want to get it off the ground.
You want me to start?
You go ahead.
All right. Well, I think you referred to the cooperative agreement that we signed with TVA back earlier this year in February. And so in the spirit of that agreement, we've been working together over the past 6 to 8 months to kind of define a path forward. And this path forward is documented and described in this letter of intent that TVA issued to Type 1 several weeks ago. So I think what's important to understand about this letter of intent, it is not a PPA, it's not an aspirational MOU, but it's really about starting the process of developing a first commercial power plant project. And in fact, there's real work going on this project as we speak. So, but I think I want to take a step back here, and because a lot of what we're talking about really refocuses the mind around commercialization, right? And that is really, again, getting back to what Andrew Lowe said earlier, first of a kind energy technology project is really two things. It's a hard engineering project and it's an infrastructure project. And you really need to bring those two things together in the right way in order to actually commercialize an actual power project that's first of a kind. And they go hand in glove because of the financing and the set of stakeholders that are involved in this thing. So a big piece of this thing that I think hopefully we'll be able to unpack is this idea of de-risking the last mile or the last 10 miles, depending on how you look at it, to commercialization. And so this letter of intent really describes in general terms, what that path is, and we're starting down that journey. But a lot of work needs to be done both on the engineering side and on the project side around the infrastructure and including the financing of it. But the financing doesn't come without the de-risking, and I think we can talk about that a little bit more if we have enough time.
Andrew?
Yeah, so agriculture is on our state seal. There's an old saying in farm communities, many hands make less work. It's what we're seeing, across the board. We've got local politicians, universities, labs, private companies, utilities, all working together, pulling on the same rope. And, with all those people contributing, it makes it much easier to get something this difficult moved forward. It's an old coal plant. It was there, since the 1960s. A lot of good bones left infrastructure-wise, even if we're past the useful life of some of the coal burning equipment. So turbine generator sets are going to be synchronous condensers at that site. We're converting them. It's going to help with, inverter-based resources on the grid. There's additional room in that same building that's not coming down as part of the demolition efforts. That's where the Infinity One prototype will, first go. Our letter of intents, got additional area of that plant that's currently under demolition that will move us towards, the possibility of a, first commercial fusion power plant.
Now, Mark, when you hear about Mark and Andrew, or Chris and Andrew, excuse me, talking about what they're building in Tennessee, how repeatable or how replicable do you think this is in other states across the country?
Well, it's replicable in certain ways, but just to put a fine point on this particular project and why this has the great potential to succeed is when you look at Oak Ridge not only has had quite a history in fusion development, but its materials, which is as important, developing new materials for the fusion systems. And they have Frontier, the high-performance computing, where they can run modeling and to determine whether or not the stellarator design, frankly, can work. So there's an awful lot of modeling that goes in here. So when you look for successful projects, you look for a combination of those things, and at Oak Ridge, you do have that. Now, you also have TVA. While it's on the old coal site, which sounds good, why is that important? Well, the infrastructure's been permitted there before. You have a community that typically embraces energy infrastructure, but it's got ties into the grid already. So you've heard probably from other panels, it's very hard to permit any new energy infrastructure today, including transmission, a big problem. With TVA and that site, you have that already there. Now, there may be some upgrades, but you've already accomplished so much of other hurdles that developers and other fusion technologies will have to overcome. That's a significant there. The other thing is, you talked about, the state, but you have state contributions, of real money going in, and you have the commitment of the state to regulate. And that's very, very important, because we've seen at the NRC, the very difficult, certainly in the world of fusion, even with SMRs, it's very, very difficult to get the combined operating licenses out of there. And so to have the regulatory environment favorable in that state, it's hard to overstate, I think, the significance of that. So when I look at this project and compare it to others, those are all the check marks that we have here. Is it going to happen overnight? No, but you have all those things going forward here. And if you can continue those things, then I think that certainly not only Tennessee, but the U.S. can help move the entire fusion industry along with these kinds of cooperative agreements in this kind of special arrangement.
So pulling on that thread a little bit, over to Chris and Andrew, for a first-of-a-kind deployment, mapping the authority's path, who has jurisdiction over what, that can be one of the hardest parts, as you kind of just described, Mark. What have you all learned about how state, federal, and local regulators interact in practice in Tennessee, and where could coordination be improved? Whoever wants to take that on first.
Well, ideally, we already operate 35-ish thousand megawatts of power generation as a utility. We've got coal, we've got gas, we've got hydro. We have a fleet of 7 traditional fission plants. So, what industrial power plant safety and regulations look like, we know, a good chunk of that. So once you make high quality steam from a fusion machine, everything past that, while it's not trivial, it's something we've done for 60, 70 years in some cases. We have programs and background and learnings that measure in the decades in those areas. And the nuclear portion is, quite frankly, a little less long-term exposure than some of the traditional fission sites, right? The waste from fission is one of the attractive parts of how you might manage it long-term with programs.
Yeah, well, the short answer to your question to me would be nothing, because that's not our role. right? And this gets back to this idea of de-risking and not trying to reinvent everything and thinking about the value chain that needs to be put together in order to take the shortest pathway to commercializing fusion. And part of that is understanding that there's actually a lot of the pieces of the value chain that already exist. And I think that is fundamental in why we ended up in Tennessee, why we're working with TVA on this first project. Because this LOI that I referred to earlier, among other things, articulates the fact that TVA, not Type 1, will build the power plant, that TVA will operate the power plant. Well, I don't have to reinvent how to build and operate power plant, which I can tell you is not an easy thing to do. And I would imagine, especially given the real focus of this conference, which is fusion plus AI, we spent a lot of time talking about how AI tools can help on the analytical side of fusion and help further improve the performance of the fusion technologies. But the other side of that is AI and the hyperscalers, they need power and they need reliable energy, right? And so the value proposition that fusion has for them is to be a source of reliable on-demand power. And I gotta imagine every hyperscaler out there would rather rely on TVA to build and operate the power plant that's gonna supply their data center than any fusion company that exists today, right? So this is about de-risking, right? And when you talk about financing a project, when you talk about a big infrastructure fund or a bank, what's going to get them comfortable enough to put down the $5+ billion it takes to build a fusion power plant? Well, one thing is to look at TVA and say, well, they're going to build the plant. They're going to build the asset. They're going to operate the asset. They're going to maintain that. That is way more comforting than to take a bet on a fusion company that's never done that before, right? And then you expand that horizon a little bit and you think about the other pieces. One of the things that is special about fusion when you compare it to fission is that properly architected, it doesn't have any nuclear quality assurance requirements on the supply chain and the construction process. And besides, and that really allows innovation to happen in an unconstrained way, or certainly in a way that is highly constrained in fission. So one of the opportunities we have in the fusion sector is to very rapidly walk down the cost curve, and that's about innovation, right? And that's where the rest of this ecosystem that exists in the Knoxville area, Oak Ridge National Lab, University of Tennessee, and the other universities in the area, they're going to be the drivers, not necessarily of the key elements of the first plant, but of the second, third, fourth, fifth that drive that innovation down, right? And then the last piece, of course, is the workforce, which, of course, there's just an incredible pipeline of talent in and around Eastern Tennessee, and you couldn't ask for anything more than that. So if I roll this all together, it's about de-risking.
Perfect segue to my next question, which is about workforce. What opportunities in the greater Knoxville area do you see to create a new workforce to support this new fusion economy? And can we grow fusion operations in an advanced manufacturing base in the Tennessee Valley? So why don't we start with Andrew or Chris? Andrew?
I'm just going to say one thing and then let Andrew riff off that. But the very first employee that we hired at Bull Run was the plant manager for the old coal plant that when it was commissioned in the 1960s was the largest, most efficient power generation device on Earth. And so this is not just about a new workforce in the pipeline, which is really important, but it's also about taking advantage of the opportunity to repurpose, the talent and the workforce that already exists. Just as important to grow new, and we always talk about repurposing infrastructure, we can also repurpose talent. And that, I think, says a lot. That's a real value proposition to the local communities.
Mm-hmm.
Yeah, so absolutely all those things, but Troy covered it a couple of panels ago. The Oak Ridge, UT Knoxville, TVA experience in the area is really something unique. It's been since the Manhattan Project in the 1940s. We've had, lots of skills in that area, and they ebb and flow a bit, and we need to definitely build up some certain areas, but there's a lot of smart people hiding around in hollers here and there. You never know based on what somebody looks like what they might know. And I've seen more, Liberty overalls wearing guys that have PhDs and something you've never heard of than you could imagine around Oak Ridge. It's taking that workforce, growing them and developing them into what we need for this. And we've got the capabilities to do that at Bull Run. There's abilities to learn, especially from first-of-a-kind units, and get that hands-on experience. Every time we build a project that is, second, third, or fourth of a kind, we look for somebody that worked on the first one that was in our fleet, or the first one somewhere else, or some other technical expertise that you only get by doing. And I think we've got the abilities to do that in East Tennessee and grow that workforce organically.
Mark, sticking with the workforce theme, what kind of national level lessons learned can we kind of extrapolate this as we start to build new fusion machines across the country, being in Tennessee or Massachusetts, Virginia, or Washington? What are some national level lessons learned that we can kind of extrapolate from this Tennessee case study?
No, I was just sitting here thinking about how far we have come and how the world really in the nuclear space has changed. I mean, 2017 we were still decommissioning following Fukushima. We had an issue across our universities of trying to attract nuclear engineering students because if you were going into that industry, you were going to be decommissioning. You might be refurbishing, but you weren't building anything. And then SMRs began to develop, and we tried mightily to try to utilize, Clinch River, other sites to try to push SMR. We were establishing centers of excellence in nuclear space to try to encourage more and more into this. Now we're sitting here, and we're actually talking about true excitement and enthusiasm of students going in to the nuclear space, but now to really embrace fusion. So the nuclear physicist, is an added attraction, and now engineering, the Stellarator, it's going to be an engineering marvel to be able to build that stuff. So you see this renewed enthusiasm here. And just to make the point on, UT, University of Tennessee at Knoxville, you have to travel around and visit our labs. And our labs, were put in places that were sort of out of the way for different reasons. People didn't want to know what was going on in those days. Of course, now they're national treasures. But you look there, and there are ecosystems there where it's usually tied to university or universities. You have this quite a bit of both intelligentsia, educated folks that really embrace that local ecosystem. And UT, Oak Ridge, they've really developed over time. And you see that in different places around. And we have multiple laboratories of our labs looking at different, fusion. This is one type of fusion, but we do have other types of fusion that's going on. And so each of them are drawing now more experts and not only into nuclear, but I made the point earlier, the reason that this potentially can reach success, I won't say faster, but you can see the potential here is at Oak Ridge. I talked about the high performance computing. So you have all these scientists that go into high performance computing there where they're doing the modeling. They may not be fusion scientists, but they're high performing computing. The materials experts, they also have 3D printing. Right? We used to take people out there to Oak Ridge to show 3D printing. Well, a lot of this new stuff is going to be made with 3D printing. That's a whole new manufacturing process. So you have all of that there at Oak Ridge. It's tied into the universities and the whole community there. So you see that, and we see that percolating now across really the country, and particularly now with the encouragement to really get into these areas where we feel real competition with China. I mean, there really is a sense of patriotism by getting into these different areas of study so that we can really gain the expertise here in this country, be proud of what we're doing, putting taxpayer dollars to work in a way that it benefits the United States on a global stage, not only here. And then the final thing I'll say about fusion, which being an energy guy, I mean, the beauty about fusion, you really can probably place these things almost anywhere. True, you need energy sources, et cetera. You need a willing utility. But if you have you know, a bunch of willing partners, think about it. You don't need to have it, you know, place where a lot of fission projects are, where you need water for cooling. You know, you're not hamstrung as you are geographically to be able to build these things. Certainly you want to build them to where they can be interconnected into the grid for electrons, but fusion can also be used for heat sources as well for other industrial applications and stuff. So that's the real excitement here. You know, just go forward, you know, 20, 30 years. Think about a future where you're going to have fusion putting electrons on the grid. I mean, this is incredible to think about. Think about the intellectual dominance that we have if we can win this. China's definitely going ahead. They're spending a whole lot more money than we are, and they're attracting global intelligentsia in the space. Well, we need to compete that. We need to say, come to the United States, be here, and you can thrive in the world of fusion development.
All right, we're almost out of time. 30 seconds left, so please stick to it. If I could get your hot takes, 15 seconds each, Chris and Andrew. 10 years from now, what do you hope that this project will have proved, looking back on it?
It'll prove by having everybody focus on staying in their swim lanes, the suppliers, the fusion technology developers, the innovators, the builders and operators. You can actually get the first generation fusion power plant online by de-risking the last mile to commercialization.
That we've led the way, that, you know, it's there, it's another, you know, great step forward out of the East Tennessee area in nuclear science.
Good note to end on. Please join me in thanking our speakers on stage.